Okay, I have a very different motivation. One thing that has been intriguing to me for quite a while is, could we use multiple protocols to collect data? One more expensive and more rigorous, one less expensive, in order to combine the data and achieve something that costs less but has the properties of the data set with the more rigorous method. So that's kind of the motivation for this. And I'll ask you to recall Randy's explanation of the data, because I'll be using some of those data to demonstrate. So just an acknowledgement and disclaimer, I do have an advisory role on RSS work. And it's really unfortunate not to have that team from NCHS here in the room. We wish circumstances were different. But we are very grateful for NCHS making these microdata available online. And I do encourage you to take a look at those. So this is a new paradigm. Probability-based web panels offer a way to collect the data faster, to be more timely, and to be able to track changes over time. But there are also other uses of probability-based panels. One is to add records to a longer data set to another survey and combine the data. Or it's to widen the survey. So you have a more rigorous designed survey, and you use the panel to augment that data to add more variables. So to use a schematic to explain it, so here the blue is the more rigorous design, the more expensive, perhaps a cross-sectional national study. While the yellow and orangish, that's the web panel data. And then in the columns, you see that there are different things going on. One is the survey weights that are developed for each one. Then the X's, those are the socio-demographic characteristics that we would measure. And then all the Y variables that we care about. And so if, for example, this is the NHIS data and the blue, that's a fairly long survey, it has a lot of data. But then the web panel data has substantial overlap on many of these substantive variables, but then adds on a lot more other variables to that data. And then we can develop different weights to combine these. We could also impute the data. So these gray boxes we could use to impute in order to widen the data, for example, and to fill in the gaps so that we have a nice rectangular data set in the end. What you don't see behind the video of me, it's a W1 and a W2. So the W1 here describes weighting approach that's more typical to what people do, which is mostly socio-demographics. And the W2 would be a very different take. And I'll ask you to think quite broadly on what we can do in weighting. So just as a quick background on the weighting paradigm, very typically it would include the socio-demographic characteristics. As you heard in the previous presentation, when you have non-probability and you use quotas, these essentially don't even work. We could add other variables that are highly correlated with non-response. And so there has been work showing that voting and volunteering are really strong predictors of survey participation. But we can take that a step further, and we can add in Y variables, right? Things that we measure on the survey topics of interest. An early example of that is actually from the Health Information National Trends study, where they use ever diagnosed with cancer and health insurance in the weight calibration. It allows us to achieve unbiased point estimates relative to the benchmark, right? We use the benchmark in the calibration, so by definition, it's going to be an unbiased estimate in the end when we pull the data. We can also reflect the uncertainty that we use benchmarks that are derived from survey data and can be quite unstable. So there are replication-based variance estimation methods that then would reflect that uncertainty, and also the certainty that we get from using Y variables in there. However, there is one big problem, especially if we want to stack the data and combine the data. We have no control over the associations that can be different in the two data sets, right? I mean, presumably one big reason why we would want to have more data is to do more multivariate analyses. And if the associations, if the covariance structure of one data set is different than the other, then we don't really have the right to combine the data because we could be biasing the estimates. Moreover, the estimates from an analysis, from a regression model, for example, would depend on the proportions of the data coming from each source, a highly undesirable situation. I'm not going to spend much time on the rapid survey system, but this is, again, the same source. This is wave 2 of the data that Randy talked about. There are a number of National Health Interview Survey variables that were added to the panel, partly for calibration, many of those for evaluation of potential bias coming in from the panel data. There were 2 probability-based panel vendors, as you saw. Again, this is the second round. And one noteworthy thing, which is not surprising for a probability-based web panel, is an overall response rate of 4%, right? So there is a lot of potential for bias going on. So I identified 32 variables that are common to NHIS and RSS2. 20 of those are health related. 4 of those are volunteering and voting. For this preliminary analysis, and I do say preliminary because this is work in process, I used listwise deletion of the RSS2, which at some point I can impute. And then most critically, weight 1 and weight 2. Weight 1 is what would be the more typical approach to weighting. I started off with a weight that was already developed as part of the study, and then just recalibrated because of the listwise deletion to sociodemographics. And then weight 2 is this other kind of paradigm and taking a look at a very different approach to weighting, where you throw in all the Y variables that you could to calibrate your estimates. So that included the 24 health and volunteering and voting related variables. And these are things like, have you ever been diagnosed with cancer? Have you seen a doctor in the past 12 months? And then evaluated the impact on bivariate associations, and then also just as a demonstration for a logistic regression that made sense with these data. I don't expect you to read the numbers, and that's why I created a heat map, right? So red is the positive, blue is the negative. What's more important is, what are these? So these are 2 correlation matrices. The first one is using weight 1. The second one is using the augmented weight 2 that uses the Y variables. These are the differences between the correlation matrix for NHIS from the Health Interview Survey and the correlation matrix from RSS2, right? So this is how different the correlations are between the benchmark survey and the survey and the RSS panel after we've done all the adjustment. One thing to point out, I think one main thing to point out, on average, the correlations were 0.03, which is not insignificant when you think about correlations in social science. And that was fairly consistent no matter how much we did the weighting, right? So what this is saying is we can weight with all the Y variables that we can identify, but if we have a different covariance structure in our panel data, then we're not going to fix that through calibration. And so that doesn't really give us the right then to stack the data sets and put them on top of each other if the intended purpose is to do multivariate analyses. And here's an example using a multivariate model. So here the dependent variable is the self-rated health as poor or fair. And then predictors like, have you ever been told that you have hypertension, high blood pressure, high cholesterol, asthma? Have you ever had cancer, and so on? So for some of these estimates, as you see, for example, for difficulty doing errands alone, that's somewhere towards the middle, the odds ratios are quite different between what we would do when we fit this model to the NHIS data and when we fit it using the RSS data, regardless of the weighting. So that means that your analytic conclusions from a multivariate analysis would be different from a pooled data set than from only the benchmark survey. I'm out of time, so I'll just skim through these. So I think the bottom line is we do need to be mindful when we use these data to pull them together, especially if we intend to combine the data together. We're probably safer to make a wider data set when we see differences like this, when we're imputing and adding variables to the benchmark survey, than we are to stack the data sets where they have different properties. And then again, as I said, this is work in process and there are additional steps that will be coming up. Thank you.